All right, so I'm so hoping for better luck. Let's see. Anyway, here's our next example. We're going to multiply f and g together, and the input's going to be 5t cubed. So I went ahead and got us started, and I'm showing that I'm going to plug in 5t cubed to f, and plug in 5t cubed for the x and g, and then we're going to multiply them together. All right, hoping for better luck here. Okay, if you remember, the f function was 2x minus 3. Yeah. 2x minus 3. So where x is, I'm going to plug in 5t cubed. So we have more work to do. We're going to have to come back here and distribute the 2. Times, as I write this times down, I'm thinking, well, and then it disappears. I'm thinking it's probably going to be best to put another grouping symbol here of some brackets. All right, now let's go to the g function. It was x squared minus 1. Oh, goodness. So x squared minus 1. So my input's not a number, it's an expression 5t cubed. And I might put this in brackets too. It just gives it a nicer, cleaner look. It gives me more direction about what I'm supposed to do. All right, let me clean this up. Let me clean this up, and then we'll multiply them together. So 2 times 5t cubed is 10t cubed. And I still have the minus 3. I don't think brackets are necessary anymore. Times. Okay, I'm going to square this quantity. So 5 squared is 25, and when I square a t cubed, I multiply the exponent, so it looks like it's 25t to the 6th minus 1. All right, we want to multiply these together. So I'm going to take the first term, distribute it with both the terms in the other binomial, and then I'll take the minus 3 and distribute it with both terms in the other one. All right, so back to the first terms being multiplied. 250. Now we add the exponents because they have their own base of t. So it looks like 250t to the 9th minus 10t cubed. Inside is going to be minus 75t to the 6th. And the product of the last two would be plus 3. I'm going to do two things that I normally wouldn't do otherwise to save time. I would have brought this down every single line, but because this pen is acting, I'm trying to save some time. That's one thing I would have otherwise done. The second thing is this. You might see that this exponent 6 is higher than 3. It's kind of rearranged. It's out of order. If I'm rewriting, I'm going to put the 6th degree first. I'm just going to switch these two. I'm not going to press my luck, though. All right, we have another example of combinations. All right, what if I'm asked to find the quotient, but my input is 3t minus 1? Well, that means I want to put in for x 3t minus 1 in the f function and input 3t minus 1 into the g function for x. Oh, it's starting to act funny. Bear with me. Okay, so in the numerator, the f function, you might remember, is 2x minus 3. So 2x minus 3. I don't have an x. I have a 3t minus 1. I know you're thrilled. We're going to have to come back and do some more work here. Now, in the denominator, the g function, if you remember, is x squared minus 1. X squared minus 1. But where x is, I'm going to insert not a number, but 3t minus 1. A lot of work, a lot of algebra. Distribute the 2. 6t minus 2 minus 3. Yep, and in the denominator, if I were to come over to some scratch paper, multiply these two out together using your preferred technique, the result of foiling, multiplying, boxing, would be these three terms right here, but I still have to go back and get the minus 1. So all that's left for me to do is clean up the numerator and the denominator. And again, if I wasn't trying to save time, because this pen is acting silly, I would have rewritten this every time. Final answer there. Okay, so we've been adding, subtracting, multiplying, and dividing with numbers, with expressions, combining functions, etc. Now it's time to move to our second objective, which is composition functions. All right, so let's look at it means to compose functions, a composition, which would not be add, subtract, multiply, or divide. Okay, I know this just kind of all of a sudden appeared, but I think it's kind of the best way. All right, it asks us to find three things, A, B, and C. Okay, it asks us to first find fog, if you will. F, composition, G. That's not a multiplication dot. We've already done that. Okay, the composition is a substitution. Okay, and notice that this notation right here is F of G of X. That's how it's read. The parentheses are read as of. So this is F composed with G or F of G of X. Okay, these two mean to perform the same computations. All right, what about G of F of G composition composed with F? Well, you could write it as G of F of X. You just kind of read it left to right. So F of X is the inside function here, whereas over here, G of X was the inside function. And what we're going to be doing is we're going to be putting the G equation inside the F equation. And the F equation here inside the G equation, if this is what we're asked to do. And finally, the third thing we're going to do is we're going to do the composition, and then we're going to evaluate the answer at 0. All right, so here's our example A. That's a lot. Three things to do with the F and G function. Okay, let's see if we can work our way out of this. A. What is F composed with G? Again, that's not a dot. That's an open circle, but it's real small. Okay, that just means take the G equation, which is second, and everything you see here gets replaced in for the X and the F equation. So you're doing a substitution. So if G is going into F, build the framework of F, meaning framework is 3, all the numbers, all the operations. Okay, leave a space for X, because what we're going to do is we're going to put G inside of F. This supposed to be an A. I think it was there. Okay, to clean it up, you're going to distribute. (20 minus 3x). So this is an add, subtract, multiply, or divided substitution. Okay, I think we satisfied A, so let's go to B. G composed with F, but think about what that means. It could be rewritten this way. Now you put F inside G. So 3x plus 5 has to go into X's spot here. So G's the outside. I'm looking at G first. I'm getting started with it. 5's good, minus is good, but where X is, I'm going to replace it with 3x plus 5. First, we want to clean it up, distribute. So 5 minus 3x minus 5. Looks like the final answer is going to be negative 3x. Okay, let's look at C. F of G of 0. I'm going to mix it up using different notation. The pen. Okay, I've already done F of G, okay, in part A, so now all I have to do is plug 0 in for that answer. So if I'm going to multiply these two together, the result, of course, is just 20. Okay, one more. Yay! I don't think the pen's going to last that long. Okay. I guess we need to know what F and G are. All right, we're going to find the same three things. All right. All right, so F composed with G, or F of G of X. We're going to put G inside of F. So go to F first, build the frame. That means keep the 2, keep the power, but where X is, I wish I had a number, but instead I have X plus 4. This is called the composition. It's just substitution. We're going to FOIL, multiply, distribute, box this, and then the last step is to multiply a 2 in. Looking good. All right, this is saying put F inside G, so go to G. All right, we've got X plus 4. But we're going to put F inside of there. Oh, easy. There's no simplifying. I'm just going to, in my next step, remove the parenthesis. Nice. Okay, and I think down here is where I'll do part C. Let's see, which was what? F of G of 0. Look back up there. Okay, so we're plugging 0 into the G function and then taking that answer and plugging it into the F function. So it's actually just us taking this that we've already found and replacing all the x's with 0. So that'll 0 out, and I'm going to go with 32. Whew, we made it through this one. Thanks, guys.